Okay, good morning, everyone. Welcome to this TALOS Open Call Second Info Day. This Info Day is focusing the pilots of TALOS project and the TALOS platform and technical requirements to help the possible applicants to this open call to learn about the requirements for their application. I would like to thank Daniel Albuquerque, Claudia, Helen, Ines, Alessandro, and Daniel and Diego for being here today and helping us in explaining everything about the TALOS project and about the TALOS Open Call. Well, I think this is all. The webinar is being recorded. You will have access to it after the webinar, and please, if you have any questions, please write them in the chat and we will try to answer them after the presentation. And I think that's all. I will give the floor now to Daniel Albuquerque, that is TALOS project coordinator. He's from EDP and he will give us an introduction to the TALOS project. Thanks, Daniel. The floor is yours. Let me stop sharing.
So thanks, Yolanda. I will share the screen now. Give me just 1 second. I hope we can all see it. So good morning. My name is Daniel Albuquerque. I work at EDP. In fact, more in the research center of the EDP group. So it is called EDP New. And I'm the coordinator of the project TALOS. Today, I want just to give you a brief overview of the project. So about the project already has 1 year. It will last for 3, so we have 2 more ahead. The total budget of the project is 10.5 million. For this open call in specific, we have a total of 1.8 million to distribute to European SMEs and startups, or even these companies that are part of the associated countries of the Horizon Europe program. The TRL levels that we are trying to achieve by the end of the project is around 6 to 7. And the overall goal of the project is to develop robots and also some digital solutions that could automate some operation and maintenance tasks in PV parks. Having that said, I would like just to briefly mention a bit the consortium that we have. So we are a consortium of around 13 companies from 7 different countries in Europe. So from Portugal, we have EDP and Inestec, an R&D center. From Spain, we have DTA, Isotrol, Alices, and RES. From Italy, we have Icons. From the Luxembourg, we have Solar Clino. From the Netherlands, we have Wageningen University. From Poland, we have Funding Box, the manager of this open call. And from Greece, we have CERT, Eden Core, and the Agricultural University of Athens. A little bit to give you a context and the motivation for the project itself. The motivation comes from the fact that most of the PV plants are getting bigger and bigger. And in just 2 years, it was predicted that the average size of a PV plant grew by quadrupled in terms of size, so quite a big change in terms of dimensions. At the same time that these plants are located in very remote places without access or easy access to O&M teams. The same is also related to the fact that in solar, we are having a lack of skilled people able to do these O&M activities. So combining the fact of having these plants quite in remote places with the lack of manpower, we face a lot of challenges currently and also for the next decades. And lastly, but not least, the fact that this solar plant, as any other power plant, is a dangerous place to work in, and it's not the safest environment that we may face. So that's also something that we want to prevent any kind of accidents and try to have our people safe. So the objectives of the project is to develop world-class robotics that could perform several operation and maintenance activities, create different kinds of digital tools from the platform that can operate all these robots to also some digital twins and AI algorithms that could detect any defects on the PV panels. We are considering different types of O&M activities, and we are trying to automate these different O&M activities from monitoring, inspection, cleaning, vegetation management, etc. And we want also to study a little bit the synergies that could arise from the fact that we have an agri-PV pilot, so which is a site where both agricultural and PV energy is being produced. And we want to understand a little bit the nexus between this energy and food production at the same time. The fact that we are developing robots, we are not developing in a standalone manner. So we have this aim of co-developing these robotic solutions together with some of the most important stakeholders, so the end users of the TALOS solutions. And finally, this open call is our one of the biggest objectives that we have in the project. So it is to identify a set of relevant challenges besides the ones that we are already taking care of within the project, and try to increase and fund increase the scope of the project and fund new ideas and other solutions that we are not currently already developing. This is a bit more the developments that we are taking care within the project. This is very specific. So we have different types of domains, more on the digital tools, such as the first two, where we have the human-robot collaboration tools. The fact that we have PV monitoring as well, so gathering all the data that is coming from the SCADA systems, from these PV plants, and also the inspections. So we are deploying some drones to do these aerial inspections already in the PV plants. And then we want to develop other autonomous robots for specific case of the conventional PV. So this is a pilot site that we have that will be further presented during this second IFO day. But for this one, we are developing a mower, so autonomous robots that can cut vegetation and collect it, and also an autonomous cleaner. For a floating PV scenario, we'll have an autonomous boat that is responsible for deploying the drone closer to the floating platforms. Within the platform itself, we are also having a cleaning robot for this specific case. Then for the agricultural monitoring and inspection, we are developing an autonomous ground vehicle, so a robot that on top of it has different sensors, and also a kind of equipment that is capable of understanding the crop growth and health. So this is just to briefly show you some examples of how these tasks, these PV operation and maintenance tasks could be automated. So in terms of the monitoring, we are talking about some robots that could do the monitoring for vineyards. Sorry, not for vineyards. I believe these images is for a vineyard, but our specific case is for a pear orchard. Then we have also some digital tools, both the digital twin and some SCADA that are integrated within our digital platform. For the inspections, we are mainly using drones that could operate visual inspections over the PV panels and try to detect some faults. For the cleaning part, we'll have different solutions. One for the conventional PV, so like a big solution for the utility scale, large utility scales PV plants, and then another solution that can fit the floating PV pallet. So a smaller robot that could be put on top of the panels to clean them. And finally, some vegetation management robots. These are not the robots that we are developing. These are just commercial products that are not autonomous, but they could give you just some hints on the kind of solutions that we may have for mowing. And in terms of impacts of the project, we have three main types of impacts. For the scientific ones, we want to develop world-class robotics to address both the O&M tasks in PV, but also for the crop monitoring for our agri-PV pilots. We want to create digital tools to support predictive maintenance and try to have this predictive maintenance very active and very efficient in this process. And finally, create new methodologies for these autonomous O&M operations in PV parks and also some agricultural fields. For the technological and economical impacts, we want to increase the reliability and availability of these PV plants. So trying to perform these operation and maintenance activities mainly during the night. With that, we also want to reduce the underperformance of these PV plants associated with the O&M issues and reduce the overall costs of O&M in PV plants. For societal impacts, we want to de-risk these operations and reduce the exposure of humans to these difficult environments as any power plants may bring to the operators. Lower the greenhouse gases emission due to the fact that we are producing more green energy. So we are producing in more consistently with the optimal point of production of these PV plants, and also upskilling the workers that are currently doing these O&M activities. For the main outcomes, we predict to decrease the underperformance of PV panels, also decrease by more than 70% the maintenance periods that we currently have without TALOS. The predicted reduce in O&M costs is of around 5%. We want to almost take humans out of the equation in terms of risk exposure, reducing it to more than 90%. And we want to see if these more frequent operation and maintenance activities could, for instance, increase the life cycle of PV panels in 3 years and also try to save more water for the cleaning activities. That's a bit it for the project itself. And now I pass the word to the pilots, I believe.
Yeah. Now we will have Helen Ellison presenting the agri-photovoltaics pilot site in TALOS. Thank you, Ellison. Helen, the floor is yours.
Good morning. Wait, I'll just have to start this. Is this the right screen mode or not? Can you see? Oh,
we can see the full PowerPoint.
Okay, wait. I was scared, afraid this was gonna happen. I think now it should work. Now
is the presentation mode
still? Oh, but is this fine?
I think go to settings, display settings, and make swap displays or something like that.
Swap
presenter view, yeah.
Like this? Okay.
Exactly.
Yeah, perfect. Thank you, Helen.
Okay. Well, good morning, everybody. I will discuss shortly about the agri-PV pilot site within TALOS, one of the 4 sites that we have. Well, as Daniel already pointed out, the activities within TALOS that we will perform in these agri-PV pilot are autonomous agricultural AGVs and AI-based agricultural monitoring. Let me see. Okay, this is the. I will first talk to you something a little bit about the Wageningen University and Research. We are located in the Netherlands, and we have about 7,000 employees and 13,000 students. Our main focus is on agriculture. That's what most people know Wageningen University from. But the research is much broader. We have food, feed, bio-based production. We have natural resources and living environment. We have society and well-being. This the Wageningen University and Research is a bit of a special construction because it's both a university, but it's also a research institute. So and they are combined. So that's a bit different from the usual universities. Well, we are located in Wageningen, which is right in the middle of the Netherlands, well, more or less. Here you can see Amsterdam and Wageningen. The pilot I will be discussing now is also located near Wageningen. Okay, agrivoltaics, shortly about what is it? We call it either agrivoltaics or agri-PV. And in the figure on the left, you can see the basic principle of agri-PV. It's basically combining agriculture with solar energy production. So the idea is that you have dual land use and that it's much more efficient than having two separate fields. But it's a challenging combination. So, for example, one of the first things that comes to mind is that you can replace the traditional structures within food production with solar panels. So in this case, you have basically replaced them. You don't have to replace the foils every 5 years, etc. This research field is quite young. It's been like 5 to 10 years now. A lot of it's a booming field. Many researchers all over the world are researching this because it provides both security for agriculture as well as sustainable energy production. Okay, what are the pros and the cons of this agrivoltaics? Well, you have less water evaporation below the panels. You could prevent heat stress. You can protect your crops from adverse weather conditions. The crops can lead to cooling of the panels. As I said, you have a local energy production and use, and the farm can actually diversify by also becoming an energy producer. There's options to integrate water management. So you can collect the water, use it for irrigation again. We also see that if it's drier below the panels, that you can actually slow down certain diseases, or they're not even there anymore. It's all of course under investigation at the moment. And as I said, you're not wasting your agricultural soil, especially in the Netherlands, where it's a very small country. We have a lot of agricultural soil, and yeah, we have to be, I don't know the English word for this. Well, it has to be preserved. Let's put it that way. Okay, then we have possible disadvantages as well, because we've been investigating this now for about 3 or 4 years in a bigger project, which is called Symbiose. What we see is actually that the crops, at least under the Dutch conditions, which is different from drier or hotter climates, we see that the plants actually grow less, and we also see that the constructions are much more complicated compared to a monofunctional solar park. And we also see that there's a lot of trade-offs there. And we also see that it's not always very easy for a farmer to adapt this technology. So in this sense, TALOS is really an addition to widening the research field and integrating the two fields. Yeah, this is very scientific. It's all this is a collection of data where you can, and the basic message here is that the more light you take away, obviously, from a plant, the less while it grows. As I said, you have to diversify between the different climates, because if you go to a very hot, dry climate, you can actually see that plants are performing better under the or between solar panels. And then some examples of AgriPV. On the left, you can see a combination of vertical bifacial panels with grass production. It's in it's in Germany. On the right upper side, you can see a bigger pilot in the Netherlands, which is focused on, well, now I see only grass there, but they're actually now going for agricultural cultivation of different crops, and these are one-axis solar trackers. And below is a combination of raspberries with overhead semi-transparent solar panels. Which leads me to the pear pilot that we are talking about today. So this is, we have in Randwijk in the Netherlands, we have built this orchard. It's about 1,200 square meters. It's not very big, but well, the investigation is really detailed, and we need to compare them to a control plot. So we have 3 panel varieties, and we have 1 control plot. Let me see. Okay, so this is an aerial view of the pear orchard. And you can clearly see the 3 varieties. 2 of them are like small panels. 1 variety is with wider panels to see if it actually has an impact below, because you have less rainfall. These are the 3 varieties that I was talking about, and you can see the pear trees nicely growing below them. What do we measure in there? Of course, electricity production. We have inverters for each panel type. We have a weather station. We monitor all the fruit stages. We monitor fruit quantity, so the total yield, the individual weight, fruit quality, so that's sugar content, morphology, also the, what is the word? Hardness? No, it's not really hardness, but just the quality of the fruit, and also the shape, because it can really vary according to different light conditions. We also look at the trees themselves and the leaves, because if you add more shading to a tree, the leaves actually grow bigger. Of course, we do detailed light measurements. We look at the soil, and we look at earwigs, which are indicator species in this orchard. But we also look to the practical implications of combining these 2 fields. And on the right, we can see actually one of the things that we are now observing in the orchard, and that is actually that because of all the activities in the orchard and also the different rain patterns, you can see that the tracks are quite damaged. So that's really something that we are also looking into. Like, it's not only the science, it's also how do you implement this? So it's good for the farmer and for the one that's actually investing in the solar panels. Okay, so these are the pear data. We've been measuring now for the 3rd year. And as expected, we see that the pear production goes down with increasing shade percentages. We also see that they contain less sugar, and they also that the skins of the pears are much smoother. At the same time, we see that there's less flowering. We see that an attention point is also the soiling of the panel, so the glass partition between them, and we also see yearly variations. So I just wanted to give you like an overview of all the things that are relevant in this orchard, the things we are running into. So it's both PV technology as well as agricultural details. So that was basically, I think this was the last slide. Yes. So this was a general overview of the AgriPV pilot. And if you have any specific questions, you can just always send me an email. That's it. Thank you for your attention.
Thanks so much, Helen. That was really, really interesting. Thank you so much.
Thanks.
Thank you. Now, I would like to introduce Ines Mendes from EDPP, that is in charge of the 2 floating PV sites that we have in Talos. Ines, the floor is yours.
Thank you, Yolanda. Hello, everyone. So let me first start by sharing my screen. I hope you're seeing it now. And
yes, but we can see the full PowerPoint. Perfect.
PowerPoint? Okay, nice.
Perfect.
So as I was Yolanda saying, I'm presenting both floating pilots. And I decided to present you a little bit about the idea of the first one and then how we come up with the second one. So I'm going to take you back to 2015 to this concept of hybridization, which was taught in EDP. This was a concept of using the same grid connection point to explore two complementary technologies. And so the idea was to complement two technologies that are very known, which is hydropower, which EDP owns most of them in Portugal, and solar or wind. And in this case, we chose floating solar. So this makes sense, as I was saying, because solar and hydro are complementary. The infrastructures could be shared. The water surface, of course, could be used. There's no competition with land, and then we have the respect for the ecosystem and a high potential for growth. So in 2015, we come up with the first pilot of this project, which is in Alto Rabagão, here in this part of Portugal, in the north. And this was the first world floating solar in a hydrodam. You can Google it and you're going to see both these news. And the pilot is here, but you're going to see more in detail next. So here's the pilot. So basically we made a test in Alto Rabagão. It's a small self-consumption solar plus a pumped hydro. This self-consumption solar, in that time, we did not have the laws in Portugal to have an hybrid. So we had to make it as a self-consumption. And this came up with some things that I'm going to share with you. First of all of the power side of the AC power side is onshore. And so that's something to take in consideration when we are going to test here in the pilot. So it's a 220 kilowatt, 840 PV panel, half a hectare, together with Alto Rabagão hydropower with 68 megawatts. This was mainly to test two things. First, the cooling effect. So these are south-oriented models, and the idea was to compare the south-oriented and 12 degrees tilt in the water with a ground-mounted one that we had close by, more or less in the same area, and to try to compare the production on both. And we actually came up with an increase in efficiency in the floating one. So the first testing was completed successfully. The second one was, of course, to understand the mooring design, how we could do the mooring system. This is Alto Rabagão here without the floating. Still, we had a 47-meter water level variation. We have four mooring lines, 2 in the north, 2 in the south. And besides all this, we wanted to see how the platform would behave with extreme weather. So here in Alto Rabagão, we have extreme winds, extreme waves, temperatures below zero, very high temperatures in the summer, a lot of rain, and also a lot of snow. So after this test, we saw that Alto Rabagão worked. This was a great idea, so we decided to move forward. And in 2022, we had the second pilot. It was a bigger one, already a hybrid. So this one was already official a hybrid. And we passed it from 220 kilowatts to the 5 megawatts in Alqueva, in the south of Portugal. Completely different lab here. We have 5 megawatts, so much more power. We had it combined with a battery itself, with a 1 megawatt battery. And the Alqueva power plant has much more strength than the Alto Rabagão. It's a 256 megawatt. So the idea here was to have a full hybrid solar plus the storage, a short duration storage and a pump hydro. So why in Alqueva? I think you can see from this picture here that Alqueva is the biggest artificial lake in Europe. So we had a lot of water to explore, so very potential for growth. We had the 500 megawatt pump hydro. We have available transmission lines. And so the idea was to test here the short versus long duration storage, VPP management system. And we knew that 3% of this water surface would equal 750 megawatts of floating solar. So this was a massive opportunity for us. But this is the pilot. And in this pilot, we decided to do a lot of things very different from Alto Rabagão. The first one was to reinvent the ideal position. So one thing that you have to see here is that the pilot is very close to the dam. So the full power of the dam gives a lot of strength to the mooring line. So we needed to change a little bit. We decided to do the east-west module orientation, very close to the ground, because we had to explore new ways of mooring system, of mooring lines that I will show you next. But this reduction of the energy generation would be compensated by the overall cost reduction for the mooring system particularly. Then, as I was mentioning, the mooring design. So we had a very short water level variation, which is 23 meters. This is the mooring system. This was actually designed in an European project as well. So the variable depth was between 72 and 75 in the same areas. So we had to be very careful where we would position each one of these mooring lines. You can see also that there is a continuous mooring line that then expands for 4 different mooring lines. So basically have a lot of connection points, but only these mooring lines that you're seeing here. And this allowed us to have a very good mooring system that the platform would not move a lot. Of course it moves, but it does not move a lot, taking in consideration the full power of the hydro power. Another thing that we decided to do was reinvent a little bit the energy transformation concept. So we decided to put the transformers floating as well. You can see here that you have one platform here and another one that is the transformers platform. There are 2 transformers, and we have the interconnection of the AC, the DC to AC, but we do not have connection, so you have to go by boat from one to the other. And then the last but not least, I think one of the most important ones and the major difference from the Alto Rabagão is the pontoon. So around the floating structure, we decided to create these platforms that that are structured that we call pontoons, that ultra high performance concrete structures. These structures allow us to have a solid location of the floating structure, as well as improve the O&M, the operation and maintenance here, safety here, as well as allowing us to, if something happens in the middle, in the floating, the mechanical structure of the full platform will stay in place. So these are the 2 pilot sites that I wanted to show for the floating PV. Thank you so much. If we have questions, please feel free to reach out.
Thanks so much, Ines. It was really, really interesting. Now I'm giving the floor to Lisandro Molina, that is in charge of the land-based PV pilot in Talos. Lisandro, the floor is yours. Hello.
Thanks to you. I will try to show my screen, even though I don't know how to do it in Zoom. Let me know if
you have the share in the bottom part of the screen.
Bottom part, resources, show caption, more. No, I cannot see this. Here is this. Okay, good. Let me know. Can you see my screen?
Not yet.
What about if I click in share?
No, it's
yeah, it works when you click the button, right?
Yeah, perfect. It's perfect now. Thank you, Lisandro.
Okay, perfect. So this is the site that we are going to use for demonstration within Talos. On the site, it's another hybridization project that we have in EDBR. In this occasion, it's the hybridization of a wind farm and 2 PV solar farms. In total, they inject 50 megawatts peak power to the grid, and it's composed of the of an old wind farm and 2 PV panels. One of the and 2 solar PV power plants. One of those solar PV power plants is the one that we are going to use as a demonstration site, and it's Cruz del Hierro. Cruz del Hierro, it's for those that like to do biking. It's located in one of the famous places to to go for cycling, and it's in the Puerto de la Cruz de Hierro. That's in the province of Avila, 90 kilometers away from Madrid. So in total, let me see if I can show the video. Can you see the video?
Yes.
Yes, okay, perfect. So the site, it's almost 40 megawatts peak power that we have in that site, in a total of 27, 28 hectares with roughly 25,000 PV panels. That means if you put one PV panel next to the other, we're going to have a row of 26 kilometers almost of PV panels. The system that currently is used in this site, it's a single axis tracker system. That means that the PV panels are going to follow the sun. So it's going to be an environment that we could consider a little bit dynamic. The site is divided into tables. Each of the tables has between 58 and 87 PV modules. As you can take a look at the site, it's a very uncontrolled environment in the sense that vegetation growth at different speed in the different site. We can have places where it's heavily impacted by erosion given the rain. There might be also a lot of stone between the free corridors. The distance between the PV panels when they are in flat position, it's almost 4.7 meters. That means that if a machine has to go through it, it should do it carefully. Once again, when the PV panels are in flat position, the distance from ground, it's something like 1 meter, 1.5 meters from ground. That's all things that we have to take into consideration if we want to have something that goes below the PV panels. Okay, so following with the presentation. There is some details that we will need to consider. As I said, the free corridor, I mean, it's the distance between the PV panels where you can go with the vehicles. It's 4.7 meters. We have vegetations that it can grow in the rainy season as fast as reaching more than 1.5 meter height in perhaps 3-4 months. That means that we will need to cut the vegetation perhaps 2 times per year. Regarding cleaning, even though we have a very humid region when it rains, there is also a drought season where we can find a lot of dust in the field. That means that we will need to clean the PV panels at least 2 times per year. And the PV panels, and the soiling that we have in the PV panels, it might be very sticky, so you will have to scrub a little bit to remove completely from the PV panels. As I mentioned, it's an uncontrolled environment. That means that we can find stones like the one I'm showing. This is very, very possible to find in the way. You cannot tell here in this picture, but this rock has almost 35, 40 centimeter tall from the ground. And also you can have big erosions in the terrain. That means that these tracks that was generated by the tractor and then eroded by the rain will difficult the transition and the navigation within the site. So this is more or less all the challenges that we face in the PV side whenever we want to deploy anything on that. One other thing that I didn't mention is that if you recall the videos, the site is in the slope of a mountain. The mountain has 1.7 1,500 meter above zero ground. That means the communication is difficult to find. And also there are seasons where it's not going to be possible to get the site because of a snow or because even of foggy, very dense foggy environment. So I don't know if you have any question, I will try to answer that. If not, that's all from my side.
Thanks so much, Lisandro. This was really, really interesting. If there is not questions, we can now present Daniel Capitan and Diego Perez, that are other technical partners in the TALOS project and are responsible for the TALOS platform and the technical requirements. So, Daniel, Diego, the floor is yours.
Thank you, Yolanda. I will make the presentation in this case.
Okay,
Give
thank
me
you,
one
Daniel.
second. I will share my screen. Oh, and right now, okay. Right now it's okay.
Perfect.
Okay. Thank you. Well, in this case, I want to comment or make a brief introduction to the platform and its the TALOS platform and its minimal requirements. It's the main technological platform that will be developed in the project and will host mainly all the digital tools and also the robotic solution that in TALOS are being developed. Okay, so in this case, if we want to call it a sort of bedrock here in TALOS. Okay, in this case, we count on a distributed platform. In this case, it's built on top of two main distributed environments that are composed by the Isotrope platform, which is more addressed and focused in the part of the analytical tools and the data analysis and so on, and the Alice's platform, which is more focused on the aspect of the IoT solutions, the robot solutions, and so on. In this case, it is foreseen that, as you already know, and for this open call, that we will interact with third-party algorithms or third-party tools, which will have two options to be integrated in the platform. In this case, these two options are based on one option, which will be on a, if we want to call it, direct integration in the TALOS platform, obviously respecting the privacy and so on, and acting as sort of black box after preliminary vulnerability analysis and so on that should be performed by in this case, by Isotrope. On the other hand, we count on a different method of integration that will be through an API and acting, if we want to call it, they can, for example, make their process in their custom environment and only connecting to the platform for example, gathering data, processing data, pre-processing data, or displaying directly the data. On the other hand, for these purposes, we have also for the robotics and also the drones and potential solution more linked to these aspects of the solutions that can be the drones and so on. For this kind of solutions, we can also a direct method of integration, which is an online API. So well, in this case, we make a differentiation, which is the offline API, more addressing the analytical tools, the data analysis, maybe those tools that are not, we want to call it in some sense, time sensitive. And the online API, which is for more the data coming from drones, robots, or IoT devices. Okay. So I don't know. I don't think that Diego, do you want to add something, or maybe for the last part?
No, as Daniel said, that the second part, the analysis part of the platform, is for the operational side of the robots, to operate the robots on real time.
Okay. So now I will comment briefly the main requirements that the tools that will be developed within this open call should fulfill, at least to be, potentially good or feasible data integration in the platform and so on. In the sense of the digital solutions or the analytical data analysis tools, we count on main 5 requirements. Well, in this case, we have the input connection, mainly the tool that will be developed should support a REST-based API to receive and unlock the data requests and so on, and accordingly to the specifications of this API. For the output connection is similar. Okay, it will be follow the same more or less methodology in a REST-based API for returning the potential operation results and so on. In terms of software, we will work on the platform with main 4 languages, which are more developed, or maybe in the versions and so on, and the interoperability with other in the guideline for applicants. In this case, are Java, Maven, Quarkus, and Knative, specifically Knative for the deployment of containers and this management and so on. And well, in terms of hardware, well, obviously these external tools should be capable of being running on with the protocols and the software requirements already mentioned. In terms of communication protocols, well, the external tools should main in this case support UDP communication. Okay, and TCP and in other aspects if needed. For robots and tools for the output connection, well, in this case, we foreseeing 4 or 5 main connection methods that are the HTTP requests, MQTT, WebSockets, socket.io, AMQP, and for 5G connectivity. In terms of software, for the robots, we expect also they can support, for example, Docker technology and Linux-based operating systems and ROS or ROS 2 gateways. In terms of for the IoT tools, it will be similar to the analytic tool, to data analysis tools. Being required to support the HTTP request response operations. In terms of communication protocols, it's expected to count on TCP UDP, similarly to also the digital tool solutions. HTTPS, MQTT, and AMQP, WSS. In this case, the tool must support also UDP, of course. As media protocols, we wanted to remark, especially the WebRTC, as the capability will require in case of robots and similar tools require it. Okay, video formats with compatibility to H.264, HTTP, or a real-time streaming protocol, or maybe also the V4L2 for Linux. And I think that with this we have given a short overview of the main requirements and about how the TALOS platform is built and how it will be possible the cooperation and the collaboration with the tools that will be developed in this first open call. From my side, this is everything. I think that I have more or less summarized everything. Diego, do you want to add something? Or
only a couple of comments regarding the integration. It depends on the kind of the system that has to be connected later on to the platform. The communication protocol used will be a little bit different. We can see a lot of different protocols, and also we have web services even exposed in the API. But maybe only communication could be done by NMAN QP, but logging and connecting and establishing the connection and opening the corresponding connection will require also HTTPS. Regarding the software and the compatibility, the API is agnostic, but at the end, it will be easier to integrate anything that comes from ROS. So it's not a must to be development on ROS, not at all. Some of the partners of the TALOS project are not working on ROS, but will be easier to integrate in this case because it's more straightforward because of the mapping of the topics that will or the information that will be exposed through the API. Only that comment. And regarding connectivity in terms of bandwidth, it depends also on the use. If we are only transmitting status data, if we have an IoT device that requires low bandwidth consumption, for sure, it could be even less than a 4G connection. If we are trying to transmit real-time video, for example, for monitoring, real-time monitoring, it will require at least 4G, 4G plus connection to be able to transmit the video in real time. So those requirements depends on the kind of application. We are contemplating all these communication protocols through the exposed API, and also it's not something that every solution will have to cover all the bullets that are exposed here. And that's all from my side.
So
Okay.
thanks so much.
Thank you, Dio.
Daniel.
I think that from our side, this everything more or less clear. And as Diego have commented, both of the APIs will be agnostic, so in some sense. So, well, in any case, there will be more information gathered for applicants and wider information about the different protocols and versions and so on. So, and also the potential interoperability with and the compatibility with other systems that maybe can be also available. So this is everything from my side. Thank you, Yolanda.
Thanks to you. Thanks so much,
comments.
Daniel. Thanks so much,
Okay,
Diego.
thank you.
It has been really insightful. And now, then, I will present a bit about the open call, even though this info day is more focused on the technicalities. I would like to summarize a bit what the TALOS open call is about. So, well, as most of you may know, TALOS launched its open call last week, and it will be open until the 3rd of December 2024 at 3 p.m. It's important for applicants to be aware of this deadline, as at 3 p.m. the system closes automatically and we cannot accept any other application after this moment, okay? Who can apply to TALOS Open Call? TALOS Open Call is looking for individual entities, both startups and SMEs, that should be registered in one of the member states of the European Union or in one of the associated countries to the Eurozone Europe. Please check the list in the guide for applicants. There are a lot of countries that are eligible now. For example, Canada and New Zealand have recently joined the Eurozone Europe program, and companies from these countries can also apply to this open call. What will these SMEs and startups do in the TALOS open call? These companies are supposed to develop robotics, AI, and data solutions in order to address one of the challenges that have been defined for the project 3 pilot scenarios. You already know the 3 pilot scenarios that have been presented by our colleagues, and the challenges will be presented in the next part of the webinar. And what are the benefits that these companies can get from the TALOS project? Startups will be covered for the 100% of their eligible cost up to 200,000 euros. And SMEs that are not the startups can receive the 70% of their eligible cost up to 140,000 euros. The definitions of a startup and SMEs are available at the guide for applicants and are the ones that are provided by the European Commission. Okay. Also, the beneficiaries from the TALOS Open Call will join a 9-month support program with the TALOS technical partners. These partners will provide technical supports with expertise in engineering integration, testing, and validation to support the selected SMEs and startups to demonstrate the added value of their solution. The support program is organized in 3 stages. The first stage that will last a month when the beneficiaries will define the individual mentoring plan and present a virtual prototype. The second stage that will last 3 months where the solutions will be developed, and the last stage with a duration of 5 months where the solutions will be integrated and demonstrated. What we recommend to anyone that wants to apply to the TALOS Open Call is go through the documentation. First, read the guide for applicants. The guide for applicants is the legal basis of the Open Call. There you will find all the eligibility criteria, how the evaluation is conducted, how the support program will be developed, and what are the requirements. Also, you have the frequently asked questions. That is a document that includes the questions that usually arise during the open call. You will find examples of budget, what are the eligible costs, other legal information, for example, conflict of interest, information about the TALOS partners and everything. Soon you will also find the subgrant agreement template only for information, but for you to know how is the contract that you will sign with TALOS Consortium if you are selected as a grantee of this open call. How to apply to the TALOS Open Call? You just need to go to the application site, click the apply button, start a new application, and fill out all the questions of the application. Then you will click submit, and that's all. What we recommend, you can submit in advance and you can still modify the application until the deadline. So what we recommend is please submit with some time, and if you need, you can go through the application again and edit everything you need. For this open call, multiple submission is allowed. Each applicant can submit up to 3 proposals, but each proposal needs to focus in a different challenge. If we detect that there is 2 applications from the same applicant to the same challenge, only the last submitted application will be considered for the evaluation. We will conduct a couple of webinars more focused on the application part of the open call. Okay, how to apply, how to manage the platform and everything. So here you have the dates, and everything will be published in the open call website. We also recommend you to join the TALOS community, where in the TALOS community we have a help desk where you can ask all the questions you have for the open call, and you will also find there the questions asked by other applicants, and you will have a lot of useful information about the TALOS project, the events we are participating in, and other very interesting insights about the project. And well, I think that's all. Just a short summary of the open call. Also, we have this email address, this help desk. If you want to send us any private question, we will be happy to help. And if it's a technical question, we will pass it to one of our technical partners to help you on that. Well, I think that's all from my side. Now we are having the presentation from Daniel Alburquerque, coordinator, and Claudia, that is in charge of the challenges of this open call, and they will try to explain a bit about them. Claudia, Daniel, the floor is yours.
Thank you, Yolanda, again. Can you see the screen?
Yeah, perfect.
Okay, so our presentation now will be more an in-depth view of the challenges that the open call has. This was a process that was done together within the consortium, and especially trying to understand together with the pilot owners what are their needs and the main constraints, and also the opportunities that they see for future innovative solutions. And we came up with this list of 18 main challenges. There is a 19th one. There is an open topic where I will explain better in a couple of minutes. As you can see in this table, we have aggregated these challenges into different types in relation to the pilots. So the first three challenges are very much agnostic on the pilot, so they can be relevant regardless of the pilot that we have. Then we have then a list of challenges that is more focused on the floating PV pilots. A second group that was aggregated for the land-based or conventional PV. And finally, a third group for the agri-PV pilot. Finally, the 19th challenge is an open topic, so it can be also applied to any pilot. And just to tell you that this order doesn't mean any kind of preferences. It was just a way to group the challenges per pilot. Also, after defining the challenges, we had to define a list of requisites for each challenge, so the applicants could already have some hints on the kind of solutions that we are looking for. So in terms of requisites, we have two differentiations between mandatory and preferential requisites. So I think that the name it's very self-explanatory, but for the mandatory requisites, we believe that are features that these solutions must met. Of course, that we can accept some exceptions to these requirements if they are very well justified in your proposal. For the preferential requisites, these are just nice to have features that in case of a draw, they can be used during the evaluation process as a break the tie. Then the last two types of requisites, they are very much related to the pilots that we have and the platform, the digital platform that we are building. And for the requisites related to the demonstration, some of the challenges we oblige that the demonstration must be done within one of our pilots in the TALOS project. But for other challenges, we give you freedom to demonstrate your solution in an equivalent pilot site. So it doesn't need to be a TALOS pilot site, but it could be a pilot site that is closer to your headquarters, for instance, and then you could demonstrate it there without spending a lot of money on travel, just because we also believe that this kind of funding should not be spent, at least a big portion of it, in traveling expenses. Then the second project-related requisites is in terms of integration. So the integration with the digital platform. So we believe that any digital and technology solution that is developed within this open call should be at least capable of being integrated with the TALOS platform, and you should prove us that your platform or your solution, digital solution, has this capability. But for other specific challenges, this integration will be completely mandatory. This is not the majority of the challenges, but for some of them, we foresee it as mandatory. And now I'll go a little bit deeper into the challenges one by one. So the first one is this BV loss aerial inspections. This is a challenge that is applied to any pilot site. So this BV loss, it stands for beyond visual line of sight. This is the idea is to have drones that could operate autonomous flights without having the human operator in a visual to have this human operator of the drone to maintain this visual contact with the drone. So we want to go a little bit beyond what is permitted, in fact, in the EU law, because this type of autonomous drone flights usually can only happen with human operators maintaining a line of sight with the drones. We can go a little bit further and try to explore together with the civil aviation entities if we can ask for any kind of regulatory sandbox to try to explore these autonomous flights and inspections of PV plants in a certain location. So of course that I'll just go briefly to these requisites. For the mandatory ones, of course that this drone should perform an autonomous flight. It shouldn't enter any kind of exclusion flight zones that are also very well defined together with the civil aviation entities. We should have always a reliable communication link and some drone data transmission, so we can have access to that information really far away from the drone. And again, the capacity to integrate with the TALOS platform, not the communication itself. It's something that is mandatory. So the capacity to integrate, the communication is other thing that we just consider it as preferential. So the integration per se, it's not mandatory for this challenge. The same as with the validation. So to demonstrate that your solution works, you can demonstrate it in an equivalent to TALOS pilot site. It doesn't need to be in one of our pilot sites. And now we can go to the second one, but now I'll pass the word to my colleague Claudia.
Thank you, Daniel. So regarding the second challenge, we have here the autonomous inspection of flights for electroluminescence imaging and analysis. This is a challenge that applies to all of the pilots, and basically it is based on the performance of these scans using automated drones, similar to the first challenge. But we wanted to analyze all the defects in the photovoltaic panels using these new imaging techniques, namely the electroluminescence techniques. And in this case, we have some very specific mandatory requisites because we want this imaging to be performed during the nighttime, especially with drones with cameras with high resolution, at least enough to identify all these defects effectively, and also to have the ability to diagnose and interpret all these electroluminescence inspections. And similarly to the first challenge that Daniel presented, we also want the capacity to integrate with the TALOS platform as a mandatory requirement, but the communication is just preferential. Also, the validation is proposed to be in one of an equivalent pilot sites as a mandatory requirement. So I think we can also now to the third challenge.
Yeah, thanks, Claudia. The third challenge is fire detection and deterrent system. This third challenge can also be applied to all pilot sites. And the idea behind it is to create a system that could identify potential fires in a very early stage in these PV plants. So the mandatory requisites is to develop this fire detection system. You have freedom to choose exactly the way you want to build the system. So it could be based on sensors, imagery, SCADA data, everything. I mean, you name it. Then should allow to remote monitoring and control. It should have an alarmistic system integrated with it. Similarly to the past two challenges, we just need the capacity to integrate with the TALOS platform, being the communication with our platforms seen as something preferential. The same as the demonstration of the solution. It should be validated in an equivalent to TALOS pilot site. And I think that's it for this challenge. Just to mention that for preferential, if you also want to add an automated fire suppression system, that would be seen as a very good addition to the fire detection system.
Now, on the deep learning-based bird deterrent system, this is the first pilot-specific challenge here that is applied to the floating PV sites that was presented here for the TALOS project. And this is a very important challenge because in the floating PV, especially in the Alqueva pilot site, there are a lot of challenges in regards to bird droppings, and there's a specific need to develop a system that can detect and deter all the birds from nesting and even interfering with the solar panels themselves. So what we are looking for here, especially in terms of the requirements, the mandatory requirements, is basically to have an advanced AI bird recognition algorithm that can, of course, repel all the birds from the PV plants while not harming in any kind of way the birds, because some of these species, they cannot be harmed in any physical way, but there needs to be any plan that does not involve for example, introducing another species because it is a protected natural area. And also, very similar to the previous challenges, we have the capacity to integrate with the TALOS platform as also a mandatory requirement, as well as the validation in an equivalent pilot site, while the communication and the validation in the floating PV pilot site would be as preferential requisites.
The fifth challenge is the autonomous detection of defects in underwater power cables. This is basically we hint that this solution should be done by AUVs, so autonomous underwater vehicles. And the idea is to have these vehicles to ensure an efficient maintenance and reliability of electrical, the reliability of the whole electrical infrastructure that is deployed underwater. For mandatory requisites is the ability to identify defects in these types of cables. It should maintain a reliable communication link and transmit some real-time data to a human operator that is far from the platform. It should operate at least up to 100 meters of depth. The underwater mission endurance must go above 30 minutes. It should not affect the underwater ecosystem. And again, regarding the capacity and the validation, it is exactly the same as the previous challenges. So it's not mandatory the integration, neither the demos in one of our pilot sites. As preferential, to have detailed visual inspections and also the ability to diagnose faults via different types of inspections using non-destructive methods.
The sixth challenge portrays the inspection and maintenance of platform anchorage and mooring lines using autonomous underwater vehicles. Also applied to the floating PV, we are looking for robots that can do all these inspection and maintenance activities to inspect and to evaluate the status of both the anchorages and the mooring lines, especially in these underwater environments that are less than 100 meters in depth, without any kind of human intervention. And as for the mandatory requisites, we are looking for the ability to inspect both the anchorages and the mooring lines using the AOV, applying different non-destructive testing techniques. We want to build a 3D mapping of all these structures, while also during the inspection mission processes to maintain reliable communications and also a real-time data transmission. And once again, the minimum operating depth should be around 100 meters, and the underwater mission endurance should be above 30 minutes. And it shouldn't impact in any other way the underwater ecosystem, and it must have the capability to be integrated with the TALOS platform, and it should also be validated at least in an equivalent TALOS pilot site. As to the preferential requisites, we are looking for these types of missions to be autonomous, so without the human intervention, and also to have the algorithms to basically detect and identify, especially identify the defects in both the anchorages and the mooring lines to understand what type of damages are in fact occurring in these types of systems. And also, as a nice to have, it should be ideal in the perfect case to have communication with the TALOS solution, and also to be able to validate this in one of the TALOS pilot sites, either Alto Rabagão or Alquiaba.
Just to highlight that for the preferential requisites, if the robot has the cleaning capabilities, would be seen also as a good solution to include in this autonomous underground vehicle. For the seventh challenge, we have the prevention of algae growth and biofueling. The idea here is to create a system that could proactively measure and try to inhibit the accumulation of this kind of organisms in the floating platforms. So for mandatory requisites, we have defined the design of solutions to prevent this algae growth, identify and measure the presence of this algae. It should not affect underwater ecosystems, so it's not without any kind of dangerous chemicals to the existing ecosystem that lives there. And the validation of this solution can be done in an equivalent to TALOS pilot site. As preferential requisites, besides the validation part, we have also the integration of potential source sensor data with our platform.
On the eighth challenge, we are looking for a remote environmental quality control applied to the floating pilots, in which a system will be developed to monitor both the water quality parameters and also provide marine fauna indicators while ensuring a compliance with all the environmental regulations that are established in that area. For mandatory requisites, we want that the system performs basically water quality measurements at two different locations. It needs to be monitored to be under the floating platform and in a control zone far from the floating platform. And we want measures such as the temperature, pH, dissolved oxygen, nutrient levels, etc. Also, we want to create a forecast model for algae growth and biofueling, and perform a fish counting at two different locations similar to the first topic. Also, it must not affect the underwater ecosystem in any kind of way, and the proposed solution should be validated and must be validated in an equivalent pilot site, while the integration of both the sensors and the validation on a real floating PV TALOS pilot site should be considered as preferential. And also, preferentially, we would like to have other types of marine life statistics in both of these locations, and also to have the capacity to differentiate between the different fish species.
For the 9th challenge, we have extended reality tools for operation and maintenance teams. This can be applied to both the floating PV and the land-based PV pilots. And the idea is to facilitate the monitoring, the remote assistance and collaboration of the O&M teams while providing real-time guidance to the on-site technicians. So to have this tool, we selected as mandatory requisites the capacity to integrate and communicate with the TALOS platform. So the integration must be completely made. The validation should be also done in one of our pilots. So it cannot be done in any kind of equivalent pilot site. It should have a visual representation of the PV plant that you choose. So you have to choose which pilot site we want to develop this tool. We must have access to real-time data, and I mean, it's both from the tool itself, but you can also have access to the data that we already have available in our platform. So anything regarding SCADA data, so data from the PV plants, or any information on the robots itself. Then we want to have some augmented reality features for real-time data visualization of these PV plants, including some alarmistics, and try to build something that could also in a visualization way could show the progress of robots mission. As preferential requisites, virtual reality for remote operation of robotized of automated O&M tasks, and the mixed reality features for robot mission triggering within these pilot sites.
On the 10th challenge, we have the pre-cleaning and soiling prevention coatings for PV panels that is applied to all of types of pilot sites. And in this case, we are looking for coatings that can reduce the accumulation of dirt and debris in the surface of the PV panels. So the coatings overall should be must be compatible with PV panels. So they must be non-corrosive. They must be durable with a lifetime of equal or more than 6 months. They must be environmentally friendly and biodegradable. They cannot have any kind of negative impact on the solar energy production, and must be easy to apply. These soiling coatings, prevention soiling coatings must be validated in one of the TALOS pilot sites, similar to the previous challenge. So it is a mandatory requirement to test it in one of our pilot sites, either floating, land-based, or the agri-PV pilots. And as a preferential requisite, we would like to see the monitoring of this coating application over time.
Yeah, just to mention that since this is not a digital solution, of course, that we don't have any kind of requirement regarding the integration of this solution with our platform. Moving to the 11th challenge, autonomous detection of defects in the underground cables. I mean, this is a challenge that we face every day in conventional PV and utility scale PV plants. And the idea is for you startups and SMEs that could develop a solution to detect the defects in these types of cables. As we don't have a real vision on the solution, we are more or less agnostic without many requisites defined. So it's just to have some algorithms that could detect these defects, or even new techniques. So not only on the digital part, but it could also be some hardware that could give you some important data. So you could detect and precisely say where exactly are these defects in the cables. This validation, it needs to be done in the land PV pilot site presented earlier. As preferential requisites, we would like to have a mapping of these underground cables, and if possible and if makes sense, the capacity to integrate and communicate with the TALOS platform.
On the 12th challenge, we bring here the biodiversity identification and monitoring applied to the land-based pilot sites. So we are looking for a system that can manage both the ecological biodiversity of the land-based PV with flora and fauna identification and monitoring systems to understand the evolution of several parameters. In this case, we are looking for, as mandatory requisites, the identification of the protected plant species, also the identification of the animal species, and as well as an alert system integrated within this to basically bring awareness of any kinds of animal intrusions that happened in the perimeter of the pilot sites. Also, as a mandatory requisite, we want it to be able to be integrated within the TALOS platform, and it must be validated in the land-based PV TALOS pilot sites. As preferential requisites, we would like to see a comprehensive baseline database of the existing biodiversity to perform a comparison analysis, and also it would be nice to have this communication established with the TALOS platform.
For the 13th challenge on soil analysis using UAVs and AGVs, we want to perform soil studies to obtain its main characteristics, especially for robot mobility decision making, so we can deploy our robots, our cleaning, vegetation cutting robots in the safest way possible. So just to tell you, UAVs, it's unmanned aerial vehicles, so basically drones, and AGVs stands for autonomous ground vehicles. As mandatory requisites, we want to perform soil characteristics analysis both on the visual part and or chemical part. Recommendation engine for have a safe robot operation in the PV plant. The capacity to integrate with the TALOS platform, and it must be validated in one of our pilot sites or the land-based or the agri-PV pilot sites. As preferential, the use of AI algorithms to analyze this soil data, and the capacity to collect samples of soil to analyze its characteristics. Finally, on the integration, we see it as just preferential requisites.
On the 14th, we are looking for a terrain analysis using also both unmanned aerial vehicles and autonomous ground vehicles to perform a topological study in both in either a land-based PV or agri-PV pilot sites. So in this case, since it is very common to have problems and changes within the terrains of these types of pilots, especially to do heavy rains or being near flooding sites, it is important to understand how can we monitor these topological changes in the terrain to be able to provide means for the robots to move within the terrain itself. So we want to have this type of study, or at least to have a platform that can make this decision, and it should have as mandatory requisites a visual analysis of the terrain, and the engine in itself should bring, or in this case, should have recommendations for robot safe operations within these types of pilots, and it should detect the terrain changes as obstacles, landslides, and other types of events with a LiDAR capture system. It also must have a capacity to be integrated with the TALOS platform, and it must be validated in one of the TALOS pilot sites, either land-based or the agri-PV. As preferential requisites, we would like to see advanced AI algorithms to analyze this terrain data, and also we would like for it to communicate with the TALOS platform.
For the fifth challenge, we have the inspection of the backsheet of the PV panels. This can be applied to both the land-based PV and also the agri-PV. And the idea is to develop sort of an autonomous ground vehicle to inspect both the back of the PV panels, the back sheet, with some thermographic cameras, and also with the capability to exactly spot the status of any electrical wiring connections and possibly misconnections that can happen at the back of these panels. So for mandatory requisites, we have the status identification of these electrical wiring connections, the visual and thermal inspection of the backsheet of PV panels, the capacity to integrate and communicate with the TALOS platform. So we see it here that the integration must be done with our platform, and the validation must also be performed in one of our pilot sites, either the land-based or the agri-PV. As preferential, the identification of loose cables and or hanging elements that could also be in the way of the robot, so it could give some problems and maybe damage the panels in the future, and the autonomous identification of defects of the PV panels using the backsheet inspection data.
On the 16th, we propose an AI-based microclimate monitoring and recommendation system applied for the agrivoltaic pilot. And we are looking for solutions that can create this microclimate system to improve both crop productivity and optimize the water usage by delivering real-time farming recommendations directly to the humans that will be operating the pilot sites and taking care of the farming activities. So this type of system, as a mandatory requisite, must have an AI algorithm to perform the analysis of crop data. It must have a smart water management system for optimization of the crop irrigation, and the recommendation engine in itself must recommend farming activities at specific dates, given the analysis performed by the microclimate system in itself, to optimize all the harvesting and the sowing and any kind of the main agriculture activities. And also it must be integrated within the TALOS platform and validated in an equivalent pilot sites. And as a preferential, we would like to see solutions that can construct, or at least solutions to involve structures to perform the collection of rainwater, and also to reuse this water in other types of applications, for example, for the panel cleaning, which in itself is another challenge that we are going to propose later on. And also, as a nice to have, we would like to see solutions that can communicate with the TALOS platform, and could be validated within our own agrivoltaic pilot sites.
For the 17th challenge, we have the autonomous agricultural practices for per orchid. The idea is to have some autonomous robots that could perform pruning, thinning, spraying, fertilizing, or harvesting without human intervention. So the idea is to have as mandatory requisites the development of AI algorithms for the identification of action areas for agricultural practices. Then the test dedicated unmanned ground vehicles for one or more agricultural practices. The capacity to integrate with the TALOS platform is seen as mandatory, and the validation can be done in equivalent to TALOS pilot sites, so in another per orchid. And as preferential, the integration with the TALOS platform and the validation itself in our agri-PV pilot.
Now, for one of the last of the challenges before the open topic, I would like to reinforce that this challenge is is something that is very interesting and not very explored in the agrivoltaics studies, because this involves the cleaning of the PV panels above the fruit trees. So we are looking for an overhead system that is at a very elevated height. So there's challenges and physical constraints to perform this task autonomously with either robots or any kind of system at these types of heights, and without disturbing the environment. So we are looking for any kind of system, or at least autonomous system, that must perform the cleaning of the PV panels while not damaging the crops, neither the soil beneath or around the panels themselves. And this solution must have the capacity to be integrated with the TALOS platform and also to be validated in our agri-PV pilot sites. As a preferential requisite, we would like to see a water management system for the cleaning, and applied to the crop irrigation, and we would like it to communicate with our TALOS platform.
And the final topic, the final challenge, is this open innovation topic. So any other solution that was not mentioned here, but that could fit this O&M reality, this automated O&M reality that we want to achieve in PV parks. It's, of course, it will be well received, and we are completely open to any kind of innovative solutions that you may find and may be able to want to develop together with us. So for the mandatory requisites, this is more or less the same for the others, but for this in specific, so we should you should show that this is a clear advancement over the state of the art, and the intention, again, the same as the whole project, is to increase a solution that right now is in the TRLs around 3 to 5, and to increase that TRL to 6, 7, or even higher than that if possible. For preferential requisites, depending a lot on the kind of solutions that you may propose, the capacity or not to integrate with the TALOS platform, and the validation, again, or not within one of our pilot sites. That's it from the challenges part. Now,
thanks so much, Daniel. Thanks so much. Now, maybe Patricia can guide us through the questions that we have had in the chat.
Patricia? Of course. Hello, everybody. I'm representing Funding Box. My name is Patricia, and I'll lead the questions and answers part. So there was a ask for Deepak. Please do share this presentation. The presentations will be shared with you later with all the attendees, so do not worry about this. The next question was from Luigi, and I believe this is addressed to Daniel Capitan. So if you are still here with us, please have that one. What is the external tool that you are looking for? Tools that should integrate it with your main control system?
In this case, well, the tool should be integrated in the TALOS platform. It's also part of the objective of the open code. These tools that will be developed within the open code should be integrated in the platform, and the two ways that I already mentioned at the beginning of my presentation. That's the main point. And well, regarding what we are looking with the external tool, it's well, mainly to answer some of the challenges that Daniel has commented and Claudia during their speech in the explanation of all the different challenges that we have. So this is my main point.
Just to add that the integration itself is very dependent on the challenge, as we just highlighted. So most of them the integration part is not mandatory, but the capacity to integrate it is seen as mandatory. So in the future, if we believe that is more profitable to both your company and also the project to have the integration done, you could do this integration without many constraints.
Perfect, thank you. The next question is from Linda. If an SME submits an application, can the budget obtained be used to pay for consultancy services from the university? Is it possible to establish a collaboration with a university? And I believe you will.
Yeah, thank you, Patricia. Well, TALOS open call and in the guide for applicants, you frequently asked questions. You have that we can admit up to a 15% of subcontracting. Okay, and this subcontracting cannot be for one of the main tasks inside the project. So you can establish this collaboration, but up to this amount, the 15% of the eligible cost. And also, you have to apply as an individual SME. You are not applying with the university, okay? That collaboration could be done afterwards.
Yeah. Consortiums are not allowed, right?
No.
Okay, thank you both. The next question, does this call require to build an entire robot or just enabling technology that then integrates within the TALOS robots?
It's more on the adaptation part. So you could build features on top of robots that are commercially available, but adapt these features to the challenge itself.
Perfect, thank you, Daniel. The next question is, does the software solution need to be an open source?
I don't believe so, but
no. No, we don't have that as a requisite for the open code.
Great, thank you. The next question from Jose, it's regarding specifically challenge number 5. So the challenge requisite, the development, the vehicle itself, to perform the required task.
Let me just check. What is the challenge number 5?
We are looking for the autonomous detection of defects in underwater power cables, either medium to high voltage, using the AUVs for applied to the floating.
Thanks, Claudia. I mean, again, you don't need to develop the vehicle if there are vehicles already on the market. What you need is to build on top of the vehicle the capacities to do all the other identification and inspections over these, for instance, the cables.
Okay, thank you. Thank you, Daniel. Thank you, Claudia. And the next question from Deepak is, are these challenges defined by customers or end users?
I mean, we don't have customers properly. But in fact, yeah, this was every challenge or most of the challenges were defined by end users.
Perfect, thank you. The next question is from Igor. Any connection to EDP at Simpson 5, building A, floor 1?
I don't know what this means, sorry.
Okay.
If any of my colleagues know, please go ahead, but I really don't know.
I think those are some offices, as I was seeing, but I don't think it's the same EDP at all.
Okay, thank you. Okay, Luigi, you see the presentation with every challenge request, so it's perfect. I do not see any other questions. So if there are any other questions, please ask them now on the chat. We've addressed all the questions. Great.
I mean, if there are any, I think people can always ask questions. Yeah, exactly.
Yes,
Send questions
Yoli
to
just
that
put
email.
it in the chat.
Thanks,
Perfect.
Yolanda.
Yes.
So, well, I think we are done. I really want to thank you all the presenters for their great presentations and all the insights about all the technicalities of the project. Thanks so much. And also thanks so much, Patricia, Anna, for your help in organizing this, and to all the attendants for your interest in the Talos Open Call. We wait for your applications, and good luck.
Exactly. Thank you so much.
Thank you for joining us.
Have a good
Thank you.
day. Bye-bye.
Thank you. Good morning.
Bye-bye.